Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to learn about series. Yes, series of numbers. Series and sequence, they are very closely related. Alright, they are very closely related. In fact, series is just the sum of the terms in the sequence. Remember last time when we talked about the sequence of numbers, okay, that is the list of numbers following certain what we call rules, certain order, certain formula, okay, that's what we call sequence, right? Now, if we add the terms in the sequence, it's become a series. Okay, like this one, we have A1, first term, we have the second term, that is A2, we have A3, the third term, up to AN. This is what we call finite sequence. Okay, we talked about that last time. And if we add all these terms together, up to nth term, then we have Sn. Okay, now let's add all these terms together. That is, we have A1 plus A2 plus A3 plus, okay, dot dot dot, and the last term we are adding is an. Okay, this is just the sum of the terms in the sequence, remember? So this is actually, we call it finite series. Okay, and we have a symbol to represent finite series, that is sum. S for sum and n to represent, okay, we are adding the terms up to the nth term. Okay, so Sn equal to A1 up to the last term is the nth term. Okay, this is what we call finite series. The sum of the terms in the sequence up to the nth term. Now, we also have what we call infinite series. Okay, it's almost the same except that, okay, the terms continues forever, okay, up to infinity. So, it's almost the same except that the term never terminate. So we have A1 plus A2 plus A3, okay, plus dot 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 plus up to AN, and also we are adding some other numbers up to infinity. Now, what is the symbol to use infinite series? Yes, we have S, that is sum also, and we have infinity like this, S infinity. Okay, that is the sum of the terms that infinitely many. Okay, the number of terms is infinitely many. Okay, then we call infinite series. Okay, the symbol is as infinity. Now let's look at this example here. Given that an equal to 2n, okay, we want to find s5. Okay, therefore we understand that, as we discussed a few minutes ago, as S5 means, okay, the sum, okay, of the terms in this sequence up to the fifth term. That is, we want to add A1 plus A2 plus A3 plus A4 plus A5, like this. All right. So what we have to do is we have to find out what is the value for each of these terms. That is, what is A1, what is A2, A3, A4, A5, okay, and then we add them up together. So, right, let's find out what is A1. A1 equal to, we have to follow this formula here, okay, An equal to 2 times n. We just substitute n equal to 1 in this case, so 2 times 1, that is 2. Okay, because 2 times n is just the multiple of n, so multiple of 2 in this case. So A2 is equal to 2 times n, and in this case is 2. 2 times 2 is 4. Okay, as you can see that A3 must be 6, right? Multiple of 2. Okay, then we have A4 equal to, of course, 8. And then A5, the last term, is equal to 10, because 2 times 5 is equal to 10. Therefore, now we are ready to write down the answer. So we want to find S5 is equal to A1. Our A1 is 2. Okay, A2 is 4 plus 6 plus 8 plus 10. Okay, this is our last term, that is A5. So let's add them up together. Okay, this 4 plus 6 is 10. 2 and 8, when we add them up, we also have 10. Okay, and we have to add another 10. So 10 plus 10 plus 10. So is equal to 30. Therefore, we already have our answer. That is S5 equal to 30. Here we are given the nth term of a sequence, that is an equal to 3n minus 1. And the problem is we want to find what is S4. That is the sum, okay, of the sequence up to terms number 4. So we write it down as 4. S4 is equal to A1 plus A2 plus A3 plus, and the last term that we want to add is A4. Okay, because we want to find S4, we stop up to A4. We have to find the value of each of this term, that is A1. Let's see, A1 equal to, okay, we have to follow that formula, 3n minus 1. So substitute first, n equal to 1, 3 times 1 minus 1. 3 minus 1 is equal to 2. Okay, that's the first term, that is A1. Now let's find what is A2. A2 equal to 3 times 2, also minus 1. 6 minus 1 is 5. Now for A3, we substitute n equal to 3. So 3 times 3 minus 1, we have 9 minus 1 is 8. Now let's see the last term, that is A4. A4 equal to 3 times 4, and we have to subtract 1. 12 minus 1 is 11. So now we can find out what is actually S4. That is the sum of, okay, 2, add with 5, add with 8, and also we have to add 11. Okay, now what's the sum here, right? So 2 and 8 is 10, 5 and 11 is 16. So 10, we have 10 plus 16, 26. Okay, therefore we have, okay, S4 in this case is equal to 26. Okay, this is our final answer. Now I want to introduce what we call summation notation. Okay, for example, if we have a sequence like this, right? We have now, and we add them up. Okay, that is become a series. We call, let's say, 3 plus 6 like this, plus 9 plus 12 and plus 15. Okay, the last term in this series is 15. Okay, starting from 3. Okay, if you still remember, this series can be, the terms in the series is actually the general term an is equal to 3 times n, or 3n. Okay, remember? Now I see it's kind of long to write like this. 3 plus 6 plus 9 plus 12 plus 16, like that is become, okay, difficult to write sometime when it is too long. So mathematicians like to write to simplify things, so they introduce what we call summation notation to simplify writing of the series. So they use like this. So instead of using n, okay, they say use I. Okay, use variable I. Okay, this I here. So this 3i coming from 3n. Just change the variable from n to I. You don't have to, but I think better to use this new variable instead of using n. So in the summation notation, we use this variable I. Okay. Now n starting from 1, that is, okay, this is n equal to 1, right? Okay, the first term, up to n equal to 5. Okay, in this case, we replace it by I starting from 1 and stop I equal to 5. So this is the first term we're starting I from 1, because starting here in this case n equal to 1, and we stop when I equal to 5. Okay, this is what we call upper limit, and this I equal to 1 is, we call it lower limit, okay. And this symbol here, okay, we call it sigma. Okay, this is the way how to write down series by using summation notation. Okay, in this problem we are given a series in the form of summation notation, that is the sum of 2i minus 3, I starting from 1 to 4. So actually what we are asked to find here is, we want to find actually is S4, okay, because the sum, the upper limit is 4, meaning to say we have to add A1, A2, A3 up to A4. So we have to add A1 plus A2 plus A3, and the last one is A4, because the upper limit here is 4. Now we have to find each one of this value. Okay, what is A1? So A1 equal to, we have to follow this, the formula, to I minus 3. So first I equal to 1, so 2 times 1 minus 3, that is 2 minus 3 is negative 1. For A2, okay, we substitute I equal to 2, so 2 times 2 minus 3, that is 4 minus 3 is equal to 1. For A3, okay, we substitute I equal to 3 this time, so 2 times 3, okay, and then we subtract 3, that is 6 minus 3 is equal to 3. And the last term, that is A4 equal to 2 times 4, of course, and then we subtract 3. Now that is 8 minus 3, that is equal to 5. Okay, so we already find out all the values for A1 up to A4, and we are ready to add them up, okay, because series mean we add all these numbers together. So now we want to find the sum of 2i minus 3 in bracket, like this, I starting from 1 to 4 is equal to, now let's add the number that we already find out, that is negative 1, that's the first term, plus 1, that is the second term, plus the third term is 3, and plus terms number 4, that is equal to 5. That is equal to negative 1 and 1 is equal to 0. 3 plus 5 is equal to 8. Okay, that will be the answer for that series. All right. Now, suppose that we are given this time a series not in the form of summation notation. Okay, they list all the numbers together like this, and we have at the end we have dot dot dot. Okay, we already discussed that last time, what we mean by when we have at the end dot 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 like that. So the question is here, we want to write the series, okay, that's given to us here with summation notation. So the numbers that they have here is very nice. That is, we have 1, okay, 4, and then we have 9, we have 16, we have 25. Okay, I hope you recognize, okay, these numbers. They are very special numbers, and we call it perfect square. Therefore, okay, in this case, we have an is equal to, actually, n square. When n equal to 1, you have 1. Okay, in this case, when n equal to 2, 2 square is equal to 4, and so on. Okay, 25, you get it because, okay, we have 5, n equal to 5, 5 square is equal to 25. Now, we just want to write it down, okay, in the form of summation notation. So we write down our sigma symbol like this. Okay, remember, okay, n we change it to I, So remember this n we are going to change to I. So we have I square. I starting from 1. Okay, and what is the upper limit of this summation notation? Now these three dots at the end represent that the sum, okay, of this series is without ending, goes to infinity. So we have to write down the upper limit is infinity like this. Okay, now this is the way how to write down, okay, this sum or this series by using summation notation. Okay, in this example, we are given a series, okay, written in a form like this. That is the sum of numbers. That is 6 plus 11 plus 16 plus 21 and plus 26. The question is asking us to write the sum using summation notation. Okay, before we can do that, we have to be able to write down what is our AN. Okay, what is AN in this case? AN equal to what? Okay, now if we look carefully at the numbers that we have in this series, we see that AN is equal to, okay, 5n plus 1. Okay, it's a multiple of 5, but each one of them we have to add 1. Okay, here 6 is 5 plus 1. Okay, for the first term you get 6 by what? By 5 times 5 times 1 plus 1. 11 you get it by 5 times 2, that is 10 plus 1. 16, okay, you get it by multiplying 5 multiplied by 3, that is 15, and then plus 1. Okay, now the last term here, that is 26. Okay, we get it by multiplying 5, okay, multiplied by 5, 25 plus 1. So this is the correct formula or the general terms for this series here. 5n an equal to 5n plus 1. Okay, as we mentioned already, that when we use summation notation, first of all, we have to write down the symbol sigma, right? Sigma like this, and we have to change, okay, the what we call the variable from n to I. So we use 5i, okay, plus 1 in bracket, of course. Now I starting from 1, okay, and stop up to n equal to 5. So this is n equal to 1 here, this is n equal to 2, okay, n equal to 3, n equal to 4, and the last term 26 here is actually when n equal to here, when here n equal to 5. So the upper limit of the summation is 5 like this. Okay, so the sum 6 plus 11 plus 16 plus 21 plus 26, if we write it by using summation notation, will be like this. So 5i plus 1 in bracket, I starting from 1 to 5. Now, let's see, okay, the series that is given in the form of fraction like this. The terms are all fractions. So how to write down, okay, this series in the form of summation notation? Okay, first of all, we have to be able to write down what is our AN. Okay, look at the patterns of the number. At the numerator, we have 1, we have 2, we have 3, we have 4. Okay, that's just n, right? Yeah, that's n. Okay, at the top we have n. How about here at the denominator? We have 2, we have 3, we have 4, we have 5. Okay, that is just n plus 1. Okay, that is n plus 1. So if we want to write it down, okay, this series by using summation notation, okay, we have to write down first the symbol for sigma, okay, and we have to write down an inside, but okay, we have to replace n by I, so we have I over I plus 1 like this. Okay, I starting from 1. Okay, look here, we have at the end of this series, we have 3 dots there to represent that this series, okay, goes to infinity. Okay, the number of terms that we have to add in this series is infinitely many. So we have to write down the upper limit is, okay, infinity. Here is another example of writing a series by using summation notation. Okay, this time we are given -1 plus 3, negative minus 5, plus 7, minus 9. Okay, so we have to recognize two things here. Okay, first of all, the sequence, that is 1, 3, 5, 7, 9, the pattern of the numbers, that's number one. Number two, we also notice in this case that the sign negative and positive, they are alternate, okay? First negative and then positive, and then negative again, and then positive, and then negative again, and so on. So we have to take care of both, okay? Both issue, we have to take care of the sequence of the numbers, and also at the same time we have to take care of the alternating of the sign from positive to negative, like that. So we have to be able to write down in this case our an, right? An equal to what? So first let's take care of the numbers, right? 1, 3, 5, 7, 9. These numbers, they are just, okay, odd numbers, right? And the formula we already discussed last time in our video on sequence of numbers, that is just 2n, yeah, 2n minus 1. Okay, that will take care of the numbers 1, 3, 5, 7, and 9. Now at the same time, I also want to, to take care of the sign that is alternating between negative and positive. So I want to write it again one more time here. An equal to, okay, so of course we have to write -1, right? Now -1 to the power what? Now first number here, if you notice, this is negative, so we have to have -1 have to the power n. Okay, have to power n, because for the first number n equal to 1, so -1 to the power 1, you have -1. Okay, so you have negative sign. So this component up here, okay, this component will take care, okay, of the sign changing from negative to positive, okay, from positive to negative, and so on. Okay, this part here will take care of the sequence of the numbers. All right, so we already have, okay, the sequence in terms of an, the formula we have it already. Okay, the question is asking us to write in terms of summation notation, so we have to write down our, okay, sigma symbol. Okay, we have -1 to the power n, so to the power I, and then we have 2i minus 1, like this. I starting from 1. Okay, let's see what's the last term here. I equal to 1, 2, 3, 4, 5. So I equal to 5. Okay, that's the way to write down in summation notation for that problem. Okay, here I just want to highlight, okay, a few things here. Okay, number one, okay, as we mentioned many times, okay, the variable we should use is I when we write down in terms of summation notation. Okay, here the variable is I. Okay, good. And I starting from 1, okay, as the lower limit, up to 5 as the upper limit. Okay, that's just fine. But, okay, it is not compulsory to use I every time. Okay, sometimes we can use other symbol also. For example, K, perfectly correct. All right, no problem. All right, like in this case here. In this case, we use the symbol K, and the formula is K square. K starting from 1 up to 5. Is it okay? Yeah, it's just fine. No problem. Okay, we can use I. We can use K like this one. No problem. Now, for the third case here, I just want to highlight. Okay, now here, I doesn't have to be starting from 1. You see here, in this case, the lower limit. Okay, I is starting from 3. Is this okay? Yeah, it's perfectly correct. No problem. Okay, we can start from I equal to 1, I equal to 7, I equal to whatever. Okay, so in this case, we start I equal to 3. And also we have to notice again that here the upper limit is infinity, means okay, this series is infinite series. Okay, the number of terms in this series is infinitely many, no ending. All right. Okay. Okay, this problem is asking us to expand. Okay, expand and evaluate. Find the sum. All right, so we are given the summation notation given like this. Okay, the summation of I square, I from 1 to 3, and then plus 1. So we have to be a little bit careful here. See, okay, for this problem, the summation is only for this part only. The summation is only for this part, you see. And then after we get the sum of this, and then, okay, after we have the sum of this, and then we add 1. Okay, lastly, we add 1. So what we have to do first is we have to find what is the sum of this. All right. So that's what we want to find. What is actually the sum of I square, I, starting from 1 to 3. All right. This is actually what we have to find is, okay, the sum. Okay, when I equal to 1, we have 1 square. Okay, 1 square. When, okay, when I equal to 2, we have 2 square, right? Then when I equal to 3, we have 3 square. So we add all these numbers together. We have, this is 1, we have 4 there. We have, here we have 9. So 9 with 1 is 10. 10 plus 4 is 14. Okay. And that is, the value here is 14. And we have to add 1. So the summation of I square, I starting from 1 to 3 is equal to 14 plus 1. That's equal to 15. Okay, that will be the answer for this problem. Now let's see here, we want to ask almost the same problem. That's asking us to expand and evaluate the sum. Okay, now in this case we are given negative 2 to the power I. Okay, we note here that I not starting from 1, it is starting from 3, okay, to 6. All right, so let's write it down. So this one will be equal to, first we substitute I equal to 3. So negative 2 to the power 3, or cube, negative 2 cube. All right, plus negative 2 to the power 4. All right, and then plus negative 2 to the power 5, and plus the last term, that is negative 2 to the power 6. Okay, so we have here negative 2 to the power 3, or cube, is what we call, okay, what we have is negative 8. Okay, here we have positive 16, yes. Here we have minus 32, and here we have 64. Okay, now let's combine this one with this one. We have 8 there. Here 64 minus 32, we have 32. Okay, we add these two numbers together. 8 plus 32 is 40. Okay, that will be the answer for this problem. The next problem here, we have the sum of 2i plus k in bracket, I starting from 1. Okay, and the last number must be I equal to k. So in this case, we have two variables in this summation notation. Okay, we have I and also we have k. But look here, we have I equal to 1, meaning to say, okay, we have to replace I and we have to leave k as it is. Okay, we should not substitute k with any number. We have to leave, okay, k as it is. Okay, so to solve this problem, what we have to do is, okay, this is just the sum. So first we substitute I. Okay, remember I, yeah, I equal to 1, and then I equal to 2, and then the last one we substitute I equal to 3. So for the first term we have to add, okay, 2 to the power 1 plus k. Okay, this is the first term. Now for the second term we have 2 square when I equal to 2. Okay, also we have to add with k for the second term. Now for the third term, what we have to do is we have 2, okay, to the power I. In this case, I equal to 3. So we have 2 cube plus k, like this. Okay, this is the first term. This is the second term, and this is the third term. Okay, we substitute the value of I, not k. All right, please take note of that. So this is equal to, for the first term we have 2 to the power 1 is 2, 2 plus k there. Okay, for the second term we have 4 plus k, and for the last term we have 8 plus k. Now let's add the variable k first. Okay, k plus k plus k, we have 3 of them, so we have 3k's, 3k. Now how about numbers? We have 2 here. Okay, we have 4 there, and then we have 8. Okay, 8 plus 2 is 10, 10 plus 4 is 14. So we have to add 14.